Hello, good afternoon, and thank you for joining us during the lunch break. We don't know how busy we are, during this week, so we really appreciate your attendance. Over the last year, Spain has been deeply involved together with other member states and also interested parties in promoting the development of measures within the IMO framework to promote the adoption of measures by the organization to reduce the underwater noise from commercial shipping. And today we are coming with the Spanish industry to share with you some examples on some concrete measures that can be implemented. In particular, a non-intrusive cavitation detection system as a new tool to achieve quiet ocean and protect marine fauna. I leave you with the expert, with Publio Beltrán, the CEO of TSI, a company with over 40 years of experience in the sector, and also with his colleagues, Santiago Molins, head of the R&D department. So, Publio, the floor is yours.
Victor, thank you very much. Good afternoon, ladies and gentlemen. It is a pleasure for me to present TSI, the new non-intrusive cavitation detection system. This system was developed to answer various needs of the naval sector and to provide a simple and cost-effective solution on the basis of TSI experience in the field of noise and vibration. I am Publio Beltrán, naval architect and marine engineer, the director of TSI. Here is the content of the presentation. As you can see, this is a brief description of our company, the activity related in the framework of the current fight of the reduction of underwater radiated noise, one overview of the underwater radiated noise and the control of the cavitation. And after that, we will present to you the particularities of the system dedicated to this activity, because it could be a very good solution, very quick, technical and flexible solution to reduce the cavitation and so to control one of the main contributors of noise to underwater radiated noise of all types of ships. Okay, this is my CV, my academic CV. As you can see, I am naval architect and marine engineer with 40 years of experience in all this type of activity. But as you can see, I have many prizes, but this is the right weight or the right indicator of the way for the cemetery of the elephant, okay? So, but this is my professional life. It's 40 years dedicated, practically dedicated to solving noise and vibration problems in the marine industry and also in the marine sector. Here you can see more. As you can see, this could be enough in order to understand why some people or some person in this auditorium call me the godfather of the underwater radiated noise, okay? So, I am representing to this company. TSI is a Técnicas y Servicios de Ingeniería, is one Spanish SME, founded in 1983, leader in noise and vibration engineering solution in the sector of industry, power generation, marine defense, and so on. So we have 40 years of experience and over than 3,700 projects dedicated to this activity. The trust is our client, is our main pillar of this activity. As you can see, TSI is a worldwide specialist service company. And TSI have a very good background because has been the only SME, in Spanish SME, involved in all the projects funded by the European Commission dedicated or focusing on reducing the underwater radiated noise. We can mention BESS project, Aqua project, Saturn project, Symphony project, and recently we have the leader, one of the leaders of the package in the low noiser project, okay? What is the context in order that you can understand with the capability and the utility of our system is what is the marine sector? The scenario is clear, the scenario, the target is integrated by over 102,000 ships. The average of these ships is 20 years old in more of the case. The distribution is well known by all of you. The great challenge, the current status of the fleet could be summarized as follows. Most of them have been designed prioritizing the aspect of the performance without other environmental aspects. Consequently, it also expected that their propellers have been designed to achieve the maximum performance and so with the high risk of cavitation. The sum of the available RON database confirms this assertion. As you can see, this is one indication of the noise radiated by different types of ships in comparison with the threshold of the marine fauna. But this contribution is mainly based in the cavitation of the propeller of the ship. Okay? This is the great challenge. So is due to their age, none of these vessels have had any requirement for underwater radiated noise included in the contractual specification. So nothing has been done to limit the reduce the underwater radiated noise of this population of current ships. Consequently, the regulatory framework of the marine sector must be phased to the two segments of ships, the new vessel or the new ship and the old ship, the ancient ship. Ancient ship that I mentioned to you, nothing has been done in the specification of this ship in order to reduce or to mitigate the underwater radiated noise by the ship. Okay? So, the pending question in that case are the following. How to do it in the most quickly and economical and feasible way? This is the eternal question in all the meetings related to the reduction of the water radiated noise by the existing ship. It is possible and convenient to do it in combination with the reduction of the greenhouse emission, but it's clear that the question of the owner at the moment is who will pay the yoke and the incentive. What are the incentives related to the investment related to this sector? A quick overview of the underwater radiated noise so clearly this. Everybody are worried about the emission, the visible emission, but only a few people are worried about the hidden enemy, but it's real, okay? It's clear that the underwater radiated noise by shipping is definitely recognized as the root cause of the increase of the noise in the ocean and disturbance of the marine fauna. But it's clear what is the equation of the sustainable equation. At the moment, everybody are worried and to apply solution for the hull, equipment, engine, propeller, and fossil. We are solving this equation with this pending variable, but this variable is not solved at the moment. But everybody are talking about this. Nobody are talking about the real equation that we need to solve. The real equation that we need to solve is this, with both variables, the visible pollution and the invisible hidden pollution. So we will apply the same solution in both cases, but we solve all the equation in this way. We will have only existing ship and ecological ship, but no, we will not have sustainable ship. So we try to convince to everybody to work together in both concern, in both worried about it. A quick overview of the importance of the underwater radiated noise. The underwater radiated noise is the vibration energy transmitted by the different components of the ship, machinery, propeller, and so to the water. This vibration is quite representative. In many cases, can be observed at 10 kilometers of distance. It's clear, but based on the investigation performed by the biological and scientific community, shipping has been recognized with the main root cause of the increase of the noise in the ocean. Okay, but in this concern, everybody knows that the propeller at the moment is definitely recognized that the propeller is not cavitating, and cavitating condition become the main contributor to the underwater radiated noise by ship. Okay, so what is the state of the art? It's clear that IMO is making a very important fighting against this topic since 2008 year, and the publication of the revised guideline is a very useful guide what has to be done in order to reduce this aspect. It's clear that in this fight, Canada, France, and Spain play a very important role in this. And so some Spanish companies are working in this fighting against this topic, okay? This is clear that the main pillar of the underwater radiated noise defined by the revised guideline are summarized in this picture, as you can see, but it's important that the author, based in their experience, fully agree with these pillars that support the strategy of the designing stage, the baseline of the underwater radiated noise predicted by calculated or experimental measurement, the clear definition of the target and the application, but sustainable balance between the reduction of underwater radiated noise and the gas emission. But of course, the incentives from our point of view should be based on the relevant underwater radiated noise signature, class notation, recognition, and so on. It's clear the answer to request this type of thing is from the Spanish company is the application of one specialized methodology that we call noise and vibration comprehensive management. This methodology is enable us to achieve new ship in compliance not only with the noise and vibration requirement on board, but also with underwater related noise requirement. This methodology enables us to provide this type of vessel. All these type of vessels are in fulfillment with the most strict underwater related noise requirement is the ISO 209 regulation. But in this role, the Spanish shipyards are playing a very significant role with very high motivation in order to produce this type of vessel. I call to all of you that this type of vessel have been defined in many European projects as technological reference how to build silent ship in all types of silent vessels. Okay? So the practical contribution of the author to this strategy could be summarized as follows. For the new ship, when the owner requests in the specification underwater radiated noise requirement, it's clear that if we apply the suitable methodology, we can meet this requirement. But it's important in this concern to follow the following recommendation: to provide the appropriate contractual specification, to select the shipyard must be committed with the target of the project, the machinery and propeller selected must be oriented to the target to reduce the underwater radiated noise, but in this concern it's very important because we have many problems with the supplier. But you are mentioning in the revised guideline, the supplier, they have to provide, by contractual requirement, to provide the load, the acoustical load, and the dynamic load submitted by the supply to the ship, and so to the water. This is important to emphasize in this aspect because we have to maintain a very high fight with the supplier in order to provide the right suitable data in order to control this aspect. Finally, it's important that you must notice that the use of the right methodology and the use of the tool recommended by the revised guideline related to finite element simulation, boundary element simulation, statistical analysis that enable to us to predict the noise radiated by the ship in the frequency range from 0 to 100 kilohertz is getting successful results. Here you can see one comparison between the theoretical approach, the requirement of the limit, the theoretical approach, and the measurement that will be performed by the same company in this case. This is a definitely confirmation that if we apply the simulation tool, if we apply the requirement, the specification, we are able to achieve silent ships, okay? This is clear, and so it is definitely confirmed. So the conclusion is the reduction of the underwater noise for the new ship is feasible and achievable. In summary, it's clear that we have solved this problem, but we have pending very big problem because we are talking about, I insist, 100 to 1,000 ships for which nothing has been done to reduce underwater radiation. In summary, it's clear that in the guideline of IMO, it recommended different action to improve, different approach to improve the underwater radiation. But as you can notice, all these approaches that are summarized here are dedicated to avoid or to minimize the cavitation. But when the owner saw this approach, the questions are the following. time, lost profit, cost, who will pay the job, incentive, and wait and see what see the other owner. The control of the cavitation in real time. This is the methodology. If finally aligned with the following recommendation of IMO regulation, reducing the propeller cavitation if an effective means to reduce underwater radiating noise. Okay, the author, based on the wide experience of engineering, the field presented a proposal to attack or to reduce or to mitigate the cavitation and by the control of this indesirable phenomenon, and so to control the noise radiated by the ship to the water. The cavitation definition is well known by all of you. Is the formation of implosion of vapor cavities in the water, and we are getting very high level of pressure in different components of the hull, or the propeller, or the appendix of the ship. It's clear that the cavitation introduced the following disadvantages: loss of propulsive performance, increased maintenance costs, reduction of comfort conditions, and it is clear that if we attack the cavitation, we will be able to improve these two aspects that are related with the emission and also with the underwater radiated noise. It's clear that it's very well known the damage due to the cavitation. This is a consequence is the increase of the maintenance cost of the ships. It's clear that the state of the art, based in the CFD, recommended also by IMO, the application for the design of this component, is clear that it is improved, but it's clear also that the problem still persists. Despite of to this design, it's clear that the reality is very hard. So, if we cannot eliminate the cavitation and its consequence, the question is why less to control it. This is the main target of this presentation. We are going to present to you a quick and technical feasible tool to reduce the underwater radiated noise by ship. Okay? It's clear that for giving the design of the control of propeller cavitation, we need to know when does cavitated start, how intensively does it occur, under the operation condition this phenomena occur, and what are the parameters that allow to identification. So, in this concern, the investigation developed by this company have been defining the following requirement: when and how the cavitation will appear. Is feasible to control the cavitation in a system with very easy installation, without modification of the hull of any complementary activity in the hull for dry dock or for other activity, and also is adaptable to any type of ship, could be applied for all types of ship, and with the ability to collect all the data, the input data related with the cavitation induced by the propeller, are talking about the ship speed, the draft, the condition of the hull, the condition of the propeller, the speed of the propeller, and so on. So, based on this requirement, and after 5 years of investigation that we start in the framework of the AQUA project, founded by the European Commission, finally, based in 5 years, funded by our company, we defined our system. This system, in brief word, you will have a brochure with more description when we finish this presentation. It's clear that it's integrated the non-intrusive cavitation stands for non-intrusive cavitation detection system. This is a monitoring system which automatically detects the system of the cavitation of ships or submarine propeller by monitoring the vibration transmitted to the hull. With only sensor installed inside the hull of the ship, we are able to discover and to measure when the cavitation appears and the intensity of this cavitation. So if we control when the cavitation appears and the intensity, we are able to define the right operation condition of one of all existing ships in order to reduce the cavitation and consequently to reduce the underwater radiated noise by the ship. The system is very easy. It's the installation of 2 or 3 accelerometers in the half part of the ship with one tachometer. It's clear that the data acquisition system enables to obtain all this information. All this information is clear that we have a post-processing that has been patented by this company, and it's clear we are able to provide to you a very graphical display, very easy display that you can see in the bridge and also in the control room. Is one indication with the speed of the propeller, or the shaft of the propeller, with the speed of the shaft of the propeller, and also the indication of the cavitation, and also the comparison with other parameters, for instance, the draft, the ship speed, and so on. It's clear that this system, the input are the quasi-static parameter, ship speed, RPM, rudder angle, draft, and so on. The type of information is RPM, accelerometer, the data processing detection. This process has been compared with the visualization of the cavitation in many cases for the experimental validation, and the output could be provided in the bridge and also in the machinery control room. The cavitation, the main feature can be summarized here: standalone integrated configuration, quick integration, visual, acoustic, alarm, and graphic display. It's clear that we are talking about, when we are talking about the cavitation occurs in the aft part of the ship. Nobody is living there, so nobody here there. So in that case, we are provide the signal, acoustic signal in the bridge or in the control room. The main benefit is increase of the lifetime, accurate control of cavitation intensity, reduction of board vibration level is clear, reduction of the underwater related noise signature, optimization of the vessel performance in terms of emission of fuel consumption, detection of undesirable operational condition of the ship, non-intrusive installation is not intrusive, could be installed in all types of ships, new and existing ships, control of silent mode, defining the right operational condition, and finally, cost-effective system. Here you can see more or less the fundamental of the principle of operation. Here you can see the sensor, the signal that we record with the sensor. It's clear that we have different amplitudes, but if we use only the vibration, we have this information, the spectrum of this information. But this is not enough. We can detect that we have cavitation, but we are not able to evaluate the intensity. But we make one post-processing and the high frequency with the modulation and so on. So this is the algorithm that has been patented. We obtain this indicator. Here, for the different conditions, we are detecting the indicator of the cavitation. This is the post-processing of the signal in the high frequency with the corresponding modulation. This is a direct indication of the cavitation. So here you can see the cavitation indicator. This is the main core of our system, and also this is the system patented. Here you can see here, but not only the spectrogram. The spectrogram enables to us to identify as with the cavitation appear and also the intensity of the cavitation. Okay? Here you can see the indication of the cavitation detected by the system with the different order of the blade path frequency. It's clear that this information, but in that case, when without cavitation, with medium cavitation, and also with severe cavitation. You can see here also very interesting thing. Here you can hear, please, I recommend it to use the phone in that case, because you can hear what is the noise radiated by the propeller when the propeller is not cavitating. And so when the propeller is cavitating, it's not here. And also when the propeller is cavitating, with the suitable location in the Okay, listen to the cavitation. This system has been validated in the framework of different research and development projects, and finally have been validated experimentally in the channel basin of El Pardo in Madrid, with the introduced cavitation of the propeller and the indication of the system. This is the delivery system provided to the Spanish Navy, one of the research department of the Spanish Navy, to detect the cavitation of the Navy ships. And here is different version, portable version, fish version. Here we are talking about 2.2 kilograms. You are able to protect your ship against the cavitation and so to reduce the underwater radiation. The conclusion is very clear. Taking into account the impossibility to eliminate the cavitation as the consequences, the growing pressure from the scientific community integration, international organization, and state flag to reduce the noise of the ocean, ship owner requirement for reducing the noise radiated into the water by the vessel, strategy value of the stealthy in military application, the first non-intrusive system for continuous control of the cavitation in real time, of identification and quantification of its severity is available, with all the advantages that it entails: reduction of consumption, emission, maintenance costs, and impact of the environment and marine fauna, developed by one SME of the Spanish sector. Thank you very much, sir, for your attention. I'm sorry to be very fast. Okay? Thank you very much.
Thank you, Publio, for the thorough presentation. We now have a very clear understanding on the current challenges to be faced by the existing ships and one of the solutions you are bringing to the table. I think we can now open the floor for questions, if any. I see the flag of Canada, please.
Thank you very much, and I will gladly take credit for giving you the nickname of the godfather of underwater noise, Publio, because it's absolutely true. Super interesting presentation. Really love to see. I know this is one of the issues we've been talking about, is having some kind of, onboard mechanism to monitor cavitation. Curious if there's kind of a follow-up on that, on how do we then improve and adjust design of the propellers to reduce the cavitation or change the cavitation inception speed, or kind of what's that next step of that, if you guys are looking at from a design perspective, that can use that information then from a design feature perspective. And maybe a second question, if I have time, if you have time, if there are no other questions, is if you have a 5-second blurb on the low noiser project that you are leading as well, and how that kind of fits into this. Thank you.
Thank you, Canada.
Sorry for this. Okay. Sorry. The first question is related to the design, improvement in the design based on this experience with the new propeller. It's very difficult because we are, since 40 years ago, we are improving the propeller in order to balance the presence of cavitation with the performance. But my experience says that if you have cavitation, you have noise. You must choose or silent or performance. The right balance is quite difficult. I am not designer, hydrodynamic designer. I am only expert in underwater radiated noise and vibration, as you will know. Okay? So this question for me is pending question, but we have been working for 50 years in order to improve the propeller, avoiding the cavitation, but the cavitation is still present. Not only the cavitation, also the sinking, and other phenomena that we need to solve in many cases. So perhaps this question should be answered by the designer of the propeller. But it's clear that with this system in which we are going to apply artificial intelligence, we are able to provide to the user of the ship or to the personnel of the ship the suitable condition to avoid the cavitation. If you avoid the cavitation, you will pass through the protected area in the most silent way. This is the more immediate application of this system, without any invasive correction, any investment in improvement of the ship or to changing the ship. This is the more essential. It's clear that based in this very big information that we are able to achieve, not only related to the operational condition, the drag condition, the RPM, the real cavitation inception cavitation speed, the real, not the provided by the channel basin, the real that we are detecting different environmental conditions, it's clear that we can improve the knowledge of our ship in order to minimize the cavitation induced by the problem. The second question related to the low noiser, the challenge of the low noiser is to provide the use of this methodology and also to provide in real time the underwater signature of the ship and to provide this information to the operation of the bridge, okay? In order to improve the right condition and to control what is the noise level induced by all type of ship into the water. This is the challenge. It will be very difficult, but we are moving in this sense using this type of system and also the transfer function by combination of the underwater signature in the early stage of the design of the project, of the sea trial of the project, combined by the measurement of vibration in the hard part or in the hull of the ship. The combination of this is the secret of the new system that will provide the low noiser project. Okay?
Thank you. I see also Malta requesting the floor, please.
Thank you very much for this very interesting presentation. I really enjoyed listening to it. The value of this of the system that you're proposing is that it provides real-time data, so detection can be taken based on this information. And from our point, the question that I have is similar also to, in a way, to the previous question made before, concerning what kind of actions exactly can be taken for existing ship. We know that slower turning propeller experiences less of a pressure drop, so this reduces the likelihood of cavitation. So my question is, what exactly concrete measures can be taken for existing ships based on this data that the system provides? Thank you.
Okay, I insist. It's clear that we are not able to provide a design aspect for to improve the propeller cavitating, the system propeller cavitating. But it's clear that we are able to get in real time and different operational conditions all the parameters that affect the original design of this propeller. We are able to provide draft condition, hull condition, propeller condition, the hull, and different, and the speed of the ship, and also RPM of the shaft and blade of the propeller. But with this information, the designer could be introduced modification in the immediate future. But the value of this system is to provide to you when you have to modify your operational condition if your existing ship in order to pass through one protected area in the most silent way. Very convincing because you are reduced and avoiding the cavitation. Because the cavitation has been recognized by all of you as the main contributor. And you can see in the different database of all the ship is the main contributor. If you control this problem, you are able to use the same ship to pass for the protected area with the lower underwater radiated noise level required. That is only the application of this system. In the future, maybe we will improve and will contribute to the designer of the propeller based on all this big data information to improve the new design. But at the moment, only with the installation of the system, you are able to achieve this position to reduce and to control in the right balance of performance and cavitation and to pass through the protected area. This is at the moment. No modification of the design is not feasible. Okay?
Thank you, Publio. We have a last question coming from Panama, please.
Thank you very much for this excellent presentation. I just had just a couple of questions out of curiosity. So the first one is, I want to understand the scope of the project. Was it like, all the spectrum that you generated, did they comprise a whole broad different variety of propellers, different types of propellers, different propeller characteristics, or was it just for a specific type of characteristic and type of propeller with specific characteristics? And is the device sensitive, to when it changed propeller, or like, is it the propeller hull combination, can it also detect this type of things? And also, I would like to hear a little bit about more about the future perspective of the project. Thank you.
Okay, thank you very much for your question. Very interesting question. It's clear that this system is able to detect when the cavitation is present in fixed propeller and variable pitch propeller. And new propeller, all propeller, we are using in different sea trial in order to detect if there is some condition, or there are some conditions of the ship in which the cavitation occurs. Okay? Especially in the marines, in the Navy ships, because if you have cavitation, you have noise, you have detectability. Okay? So, first, this system is applicable for all type of propeller, new and existing one, fish and piece, variable piece propeller. Okay? Secondly, the advance of the new projects are focused in this. The combination of this information, because you control the cavitation, as you control by combination with the transfer function of the structural board noise induced in the ship, combined with the database of the underwater radiated noise measurement during the sea trial of one ship, by the combination of this information, you could be able, we have some example in other presentation, you could be able to estimate the underwater signature of the ship in any operational condition of the ship, not in the typical operational condition in which the sea trial of underwater sea trial or the underwater radiated noise measurement have been performed. In any operational condition of the ship. By combination, insist in the information of different accelerometer installed in the hull, by the transfer function using the database, the underwater baseline of the ship, by the combination of this information, could be able to provide, this is the target of this project, to provide a system that could be able to provide to the user of the ship what is the underwater radiated noise signature of the ship in any operational condition. This is the new challenge.
Thank you very much, Publio. I think we can all agree on congratulating you. So I see a card from Clea, please. I would suggest just, it's going to be the last one, because we also need to allow you to go to the cafeteria for your lunch. So we may have another round of Publio and his colleagues are going to be around. So every other question that you need to address to them, please, you can use the rest of the day. But Clea, please, you have the floor.
Thank you for the presentation and the attention to such an important issue. There was one point in your presentation where you characterized some ships that for nothing has been done. And I just wanted to challenge that presumption, because I know at least for passenger ships, significant work has been done for cavitation reduction. And while it may still benefit from the technology and experience you're offering here, in addition to the impacts for underwater radiated noise, having a cast of individuals on board that also detect that cavitation, there's been significant advancements there. So just want to ensure that that's accounted for in how this is characterized. Thanks.
Very much for your question. We are worried about the cavitation, but not only from the underwater radiated noise impact. This is proven by all of you. It's affected in the revised guideline of IMO. But it's clear that if you improve the cavitation, you improve the comfort of the ship at the low cost. If you have cavitation in one passenger ship, you will need to spend a lot of money to increase the acoustical insulation to improve the comfort. So if you increase the cost of the material insulation, you increase the weight. If you increase the weight, you reduce the speed. To get the same speed, you will need to increase the power. If you increase the power, you increase the emission. So it's related with all. If you improve the cavitation, you improve the comfort on board and also the comfort for the marine fauna. Please. That's all.
Thank you, Publio, yet again.
Thank you very much to all of you.
I may congratulate you not only because of the presentation, but also for your entire career working passionately, devoting to this issue. The presentation will be uploaded in the virtual portal, so feel free to download. Thank you so much. Enjoy your lunch. You have also brochures if you need for more further information about the project.
Thank you very much, sir. Thank you very much.